Hi.
Hey.
How's it going?
Good. Just came back from class.
Stats?
Yeah.
How was the test?
I think I bombed it.
Oh my god, what happened?
I just didn't understand the back.
What question was it about?
It was the one about the flowers. The
The
plants.
flowers?
Yeah.
The standard error one?
Yeah. The one asking about the critical value and statistic. I just didn't understand. I just need someone to help me walk me through it.
I got you. I know how to do it. Alright, so what are you confused on?
So it's this question. Clara wants to test to see if plants grow taller in the sun than in the shade. She has 3 plants that she raises in the sun and 4 that she raises in the shade. The plants in the sun average 40 inches with a standard deviation of 10 inches. The plants in the shade average 21.5 inches with a standard deviation of 9 inches. Calculate the t-statistic. State the critical value and come to a conclusion about growing plants in the sun versus the shade. Let alpha be 0.05 and let the test be two-tailed. Show our work.
Okay, so what we're going to have to do is we're going to use a formula. So you're going to use a t-test, and we're going to use a t-test because we're going to check to see if we can reject the null, meaning to see if there's a difference if we will have them in the sun or in the shade. So our observed, it's going to be our 2 means. Okay, so we're going to use the t because we're trying to see if we're going to reject the null. The null being if there is a difference. So the null is that there's no difference, and so we're trying to see if there is a difference between putting the plants in the sun or in the shade. So we're going to do observed and is expected. And then, so this is 0. And then the observed is going to be our means of both of these. So 30 plus 40 plus 50 divided by 3 is 40. So we're going to do 40 minus the means of these, which is 21.5, and then minus 0. So now we have to find the standard error. Okay, so now that we need to find standard error, what do we do?
Oh, I think I remember. We have to use the standard error formula.
Yeah.
And I think because we have homogeneity of variance, meaning that this one is not twice as large as this one, we can use this formula. Okay,
so now that you wrote down this formula, explain to me what this means.
I think that's the pooled variance, right?
Yeah.
Okay.
So how does that fit in with, how do we find pooled variance?
Oh, I think we need to use this formula.
Yeah, correct.
Which is variance times variance of the first sample times degrees of freedom plus variance of the second sample times degrees of freedom over the first sample plus the second sample minus 2.
There you go. So I already have these out for you, but the way I found it was that I squared the standard deviation. The standard deviation of the one with the sun was 10, so I squared it, which is 100. And then the other one that was in the shade, the standard deviation was 9, and so I squared it, and then I got 81, and that's how I found it. So 100, we have to put, so our first one is 100 times our degrees of freedom. So we have 3 of these, and our degrees of freedom is the number minus 1. So then we're going to have 2 plus our other one, which is 81, times the degrees of freedom, which is 4. Minus 1 is 3. Over n1, which is 3, plus n2, which is 4, minus 2. So we're going to do all the math, and then we're going to get as our pooled variance, it's going to be 88.6. We're not done yet. So now you have to plug it in here. So that's going to be, we're going to do 88.6 over n1, which is 3, plus the same thing, 88.6 over 4. And then we're going to square root that. Okay, so now that we found the standard error, which is 7.188, we're going to put it in here, which is where our standard error should be. 7.188. Once we do the math, we should be getting 2.573. But we're not done yet. We still need to find the critical value and degrees of freedom to see if we're going to reject the null.
I think that's where I'm confused. I don't know how to find the critical value.
The critical value? Okay, that one is easy. Don't worry. Okay, so to find the critical value, we need to know if it is two-tailed and if what our alpha is. So our alpha is 0.05, and in the equation it says that it's a two-tailed test. So what we're going to do is we're going to look at our t-table. And our t-table says we have to look first our degrees of freedom, which is 7 minus 2, which is 5. So 5, and then it was 0.5 because it's too tall. So it should be our critical value 2.571. And our degrees of freedom, we just said that right now, was 5. We used to define it. So, as you can see, our t value is bigger than our CV. So that means we're able to reject the null. Therefore, there is a difference between putting plants in the sun and in the shade. So that you're able to visualize this better, we're going to have our normal graph, and then our CV, which is, for example, let's say here, 2.571. And then our t is past this by literally 0.003, so which is like right here, or a little bit closer. So since it's in this area, that means we're able to reject the null.